Okay guys, this week we're going to be talking about a few different things. It's actually posted in Canvas in the week 2 overview and to-do list. We're going to become familiar with some of the basic types of data transfer, the basic function of the World Wide Web, the OSI model, the difference between authorization and authentication, and the different methods of authentication. The reason we're going through this in the security class in the web security class is because in order to understand how to secure, to secure your computers, you have to at least know the basic functions of the internet. So I'm going to start by going over an Internet 101 here. You can see that a picture, a text message, or an email that gets sent from one device to the other. It can go through several different medians, and if you're sending a message to someone across the world, odds are it's going through probably wireless from your home computer to your home router, and then possibly hardwired from there to your internet service provider, and then it'll eventually probably end up in fiber optic, which can go miles and miles and miles without any data loss. The absolute cheapest way to date is, well, it'd be wireless, but wireless goes a very short distance. Hardwired copper is the cheapest way, and it's pretty fast, and it's sufficient for most applications, but it can't go as far as fiber optic, which actually uses light. It shoots light through basically a wire of glass, and the light bounces off the sides of the glass. So it's very fast, very efficient, and it's also extremely hard to hack. Once data is placed into a fiber optic wire, to splice fiber optic wire it's a profession. It's a fairly well paid profession. When you cut the wire, you have to polish off the edges of the glass perfectly in order to splice into it. So fiber optic is the most difficult to hack. Wireless is probably the easiest to hack or break into, depending on where it's being used. If the copper cables are well stowed away and physically protected in a building or something of that nature, then copper would be the next most secure method of data transfer. But if the copper wire is exposed and easy to get to, it is not very hard to splice into a copper wire using an RJ45 jack. You could probably do it in 5 minutes if you know what you're doing, and then you could use Wireshark and intercept all of the data being transferred. But the downside to wireless is you can be outside the building with your laptop, and if you're good, you can you can tap that. So the order of security would be fiber optic cable is the most secure, then usually copper, and then wireless. So let me see here. Is there anything else in here that I want to elaborate on? So it explains that binary information is zeros and ones, yeses or nos. It explains that how many songs are in a byte, or how many bits are in a byte, how many bytes are in a megabyte, how many bytes are in a kilobyte. 1,000 bytes together is a kilobyte. Kilo means 1,000. 1,000 kilobytes is a megabyte, and 1,000 of those is a gigabyte. Let me see, what else do we have in here? I think I've pretty much covered. The rest of this is pretty cut and dry. You guys can just read through this, and it'll give you a basic understanding of how data is transferred. Wireless is obviously done through electronic pulses, which sends out zeros and ones. And wireless internet. Let me see if I can do this on Paint. Wireless internet would have a carrier wave, and this represents a sinusoidal wave. Now on that wave, your receiver would transmit a certain frequency, your transmitter would transmit a certain frequency, which your receiver was calibrated to accept. Just like any radio, when you tune in the radio of your car, you tune into Eagle 107.5. You're actually turning a variable capacitor, which changes what wave that radio will accept. The binary data is actually transferred as very small fluctuations in this wave. So what I'm representing here is this is supposed to be the zeros and ones, the ones being the high, the zeros being the lows. And it's actually very small fluctuations in the voltage of the carrier wave. Now with copper, it's a little bit different. They can you can literally they use carrier waves too, but you could also just pump out straight plus 5 volts. This might represent three binary ones, then take it down to 0, and maybe that represents 5 binary ones. And it can literally use the plus 5 volts or the 0 volts at the ground level to transmit binary data. Fiber optic cable gets way more complicated. It uses pulses of light, almost like SOS code in a way. Like I said, it's lightning fast, it's the most secure, but it is expensive, and that is the downfall to that. So that is the lecture for, maybe I should save this as kind of a masterpiece. No, I won't. That's the lecture for the first assignment. That hopefully shines some light on things. Just read through it, and towards the bottom, or I'm sorry, this would be the second assignment. Your first was the OSI, but towards the bottom are some questions to be answered. So have a blast, and let me know if you have any questions.